the first piece of science news for today, which is about space. So, you know that I love this because I always talk about how much I love space. And this one is specifically, they were able to track the bubbles on a star's surface. So, we're able to do this with the sun, but we've never been able to do this with another star because you can't get enough resolution. So, a study led by Wouter Vlemings, a professor at Chalmers University of Technology in Sweden, was able to do this. So, when I'm talking about bubbles, I'm talking about bubbles of gas in the surface of the stars, because stars produce a lot of energy in their cores through nuclear fusion. And this tends to be carried out in what's called convection currents, of where basically the gases all kind of rotating around and like bringing the hot gas to the surface and the gas down. And that's how our mantle works in the earth of heating the earth. Because of this, there are a lot of these different bubbles that happen due to that. And it is thought that this type of process is responsible for stellar winds that carry out the elements that are formed only in the core of the star. And so they were able to look exactly at these bubbles with images on a star called R Doradus, and it was done by using the Atacama Large Millimeter Submillimeter Array, which is also known as ALMA. So R Doradus is a red giant star and has a diameter about 350 times the size of the sun, which is insane. It's about 180 light years away, so quite a bit away, but not super far away, which makes sense of why we're able to see the surface of it. And because of how large it is and how it is kind of close-ish, we can actually, yeah, that was one reason why they chose it for the target. And the thing that's especially interesting with it is its mass is actually similar to our sun, which means that our Doradus is what the sun could look like in what the press release says is 5 billion years. So when the sun gets to the point of turning into a red giant star, this is what our star could look like. So this is one reason why it's also really important to study this. And the other thing, there's a couple of other things that are interesting. So these bubbles are about 75 times the size of our sun, which is, whew, that is definitely large. And we're also able to measure how fast they were, which is really important because of the convection currents. And these apparently appear to move on a 1 month cycle, which is extremely fast and a lot faster than what researchers were expecting based off of the sun. And there's not really any known thing yet of why there's a difference, but they're definitely going to be studying that because that is a really interesting time period.